Hi, I hope find you well today. So I now get everyone's group presentation. So bless you. So one of the main problem I noticed, this is the group, okay? So one of the main problem that we have now is we have 41 students. Even I give 5 minutes to each of you, even without Q&A, even if everything goes smoothly, we'll have to take 260 minutes, right? 240. Then that means even though we don't do any break, it will require 4 hours, right? So, and so the way that I try to resolve this problem would be to move the class that do next week together with the week after. So the way I would do that means next week we don't have class, but we'll have a much longer for other day. Yeah. Together. The same day we finish all the presentation. So this will be technically the last class that I taught. After that, there will be you talk, and then will be the thing. Okay. So what I meant is, this is the time, right? So suppose 17 is a presentation and 24 is our exam day, right? So I would combine the 10 and 17 at a nice lecture theater where you present, okay? And everyone would, in the group, will have to present. So I would then your presentation will be the mark based on your classmate, also by me. And I need to make sure that everyone knows, so everyone have to present. Okay. This is the only way that I know actually you know something, right? So I'll give more detail later. So you're not in this room, but in the room in the I think in the Eric C. So we're next to the Saraman Hall Theater. There's a I'll send out more detail later today. Okay. So that would be if you want to go home early, let me know. I will schedule your group earlier. Okay. But otherwise, I would expect you to be there because presenting and listening to presentation is very important. To at least you need to have patience to listen, the minimum thing. That is very important skills when you go to business world, right? It's not just you talk, but you have to have patience to listen. Okay. So unless you have some legitimate reason, you can. I assume that you shouldn't be absent from that. Okay. You're expected to everyone in the group should present, and same time, I mean, on that day, I expect you to give me the written report as well. Okay. I think that is written in there already. Okay. So there's no. So I will try to squeeze the thing out in the one class, but that's no. Don't worry, there's no loss of anything because the last four topic is basically conceptual rather than calculation. Because today we're covering the causal framework panel data. If you take this class, that will be 2 courses. So that's the way we cover everything anyway. So I guess there's not too much of loss of that, but I guess presentation, and I'll give you comment how you present, and I think it's more important, especially you learn from this is several field courses you learn from B school, right? So from B school you learn how to present, right? It's important. Although I don't think I'm not a very good presenter, but I think I know how to do good presentation. Okay, so I hope that would be helpful. So I think last class we already finished the machine learning, right? This comparison. I hope you still remember this important slide. And of course, I'm pretty sure that none of you remember any details after one semester, right? Maybe a few months later, probably you forgot everything. But the main thing is not to remember the detail, but rather you know there are several techniques to do prediction, right? That is the main goal of this. And there you can see there are many things, but I want to emphasize one thing is OLS is indeed not as bad as you think, at least in terms of prediction. Okay, so that means that whenever you try to do prediction, if possible, OLS will not be a big issue. Okay, of course, if you have a lot of data, you don't know which to choose as an IT manager, right? You have a large number of features, number of mix, right? And then in that case, machine learning can help you to select, right? Because you really don't have a guidance on what to pick. Okay, and that comes to handy because a lot of things you don't have to think, right? The machine do it for you. Although the cost is, if the machine choose, you don't know why they choose it and what's the reason. Okay, and you may have hard time to tell your boss why is the case, but if the boss doesn't care, just care the result, then it's fine, right? When you only care about result with the prediction, you're not interested in finding out what's going on. You're just interested in how to predict, then that's fine. Okay, so that ends the machine learning. And today we talk about the causal framework, which means that we care about actually what happened, not just prediction. Okay, so that's basically the things that we talk about today. Although today I know it's going to a little bit rush, but I hope that things will be clear. Okay, so this is covering two parts: is causal analysis, okay, and how to use observational study. I guess as an IT manager, you don't worry too much about this. So that's why it's okay that I little bit skim for a little bit, because as an IT manager, usually you work for a company, I suppose, or you're a startup, then you would try to test different thing in the company, right? You use beta version or this and that, and you collect data by changing policy. So in that case, you actually do have the data that is experimental data. Actually, you don't have to worry about this, okay? But if you are talking about in general case where you only have observational data, right? Which means the data is not collected by you, right? You just observe something happen at the same time. So it's very difficult to establish causality here. What caused what is very difficult, okay? And so I will be very brief, because even if I'm a master student, I didn't learn that. I only learned this thing during my Ph.D. And but now this thing become trickling down to the undergrad and master program. So but we kind of go math, right? So I just give you the idea what's going on there. And if you want to learn, then you can learn further. But I suppose that the machine learning, the OLS part, is the main thing that you use most often, because that would be the key. But just to sum up what we do, okay? So I guess is go for the slides, okay? So the idea is you have Y, you have something we want to know, and X is the variable we want to establish how X change lead to Y. So remember regression, we didn't talk about whether X cause Y, or there's something actually cause change in both X and Y. So we don't distinguish that. As long as X is useful to predict, then we use it, right? We don't care about actually working behind. Here, we need to understand whether the changes is going to help, okay? So you can imagine X is something you can control sometime, right? You are going to, as an IT manager, maybe you are talking about changing different type of different type of the I don't know, the interface, right? Requiring two-step authorization, right? Or require email verification, or different type of protocol. You talk to the staff, right? How it changed, right? And then this is the thing that you would try to see, right? Or you want to see, okay, now I have organizing an online game. Now I have to introduce a new skin, right? Or introduce a new character that require you to pay, right? How does it affect, right? Or I have a discount of the special character, right? Or special premium membership. How does it affect my sales, and so on and so forth, right? Or very often we have online is people try to sell, right? It's 带货, right? So some people try to sell something, right? And the problem is if the company going to have somewhere famous people try to sell that, is it going to help the sales or not, right? Because we really don't know, right? So that's a question here. Okay, and the framework that actually talk about causality is very famous. The standard framework is called the potential outcome model, which essentially said the following. So what you actually observe is called yi. I is the guy number one. So you have I maybe 1, 2, 3, 4, 5 to n, right? Y1 is what you observe, okay? But what you observe is just one of the potential outcome, okay? And if that guy got treated is 1, the other guy got not treated 0. So treatment, you can imagine that is like whether this guy have seen your advertising or not, right? So if they see you advertise, they may buy your product, right? Or this guy, this is one, maybe this is the period that I hire a famous person to sell the product, right? But do you remember that there's no parallel universe? So either you observe one or the other, right? You can imagine the treatment is considered, say, taking a medicine. The easiest thing is taking medicine, right? There are many people, right? You may observe whether how healthy he is if he takes the medicine or he doesn't, right? And the problem is you only observe one of them, right? At the same time. So now I take the medicine, look at my heart rate, or I didn't take, what's my heart rate? But I can't at the same time if we can observe both for each person, right? So that is a problem. So one of them must be counterfactual, okay? So that is the most difficult part because we want to extend causality is to take a difference. That is called the treatment effect. I think it's the next slide. Okay? It's the treatment effect, right? Is I want to look at the guy actually take the medicine or I didn't, right? The problem of you would consider is, okay, I don't take the medicine. You can test my health or heart rate, right? That is 0. Then you was, okay, then why don't I take the medicine, right? And then see, right? Why don't I, this is my treatment effect. The problem is, okay, the main problem is I take the medicine, it's not instantaneous, right? It takes some time for the medical indicator to come up, right? But do remember that my body is not a constant. I support the disease, even though if I don't take any medicine, then I recover automatically, even though I don't do anything. So in the same universe, same time, I either take the medicine, I didn't take, right? So that is a problem, okay? So you're only able to observe one of them, right? Either you give him the medicine or you don't, okay? So that's a problem. You never observe this, okay? So that is exactly why always is a problem to establish causality. You never, unless the medicine is instantaneous, right? It takes time. Often all the treatment takes time, right? Suppose you have, as I said, right? You hire a famous guy to sell your product, right? It's not instantaneous, right? It takes some time for things to come out, right? So it's not entirely clear that the other thing would happen in the background, as I said, in the example of taking medicine, my body also change, right? Even though if I don't do anything, actually I may recover, right? So that's a problem. So that is a problem. You're never able to find it. You need to make some assumption in order to discover that, okay? And of course, the problem is further complicated by the fact that each individual are different, okay? You guys are more healthy, you are younger, to take a medicine will be more useful. For me, older, less healthy, right? Then it would be not very useful, right? So it can be very, very difficult to estimate this guy, okay? So this is just hypothetical. We can never know this one, okay? So what we actually would do is look at this is something we can try to discover. It's called average treatment effect, okay? It's looking at average over all the people, look at the average, Okay. And that is what we want to look at. Okay. By averaging, we hope to average out the heterogeneity, right? And kind of solve measurement problem, right? We try to look at, okay, people with similar characteristic, look at their health indicator, whether after taking medicine, do they recover, how they recover. Those who don't, who do not, then you do a treatment group or control group, right? That's what you do in science, right? That's how you see, you learn experiment, right? How you test a chemical, how to test a medicine, right? A group of people, right? Take a medicine, group of them take the placebo, right? Or do something else, right? Look at compare and contrast, right? Control group, treatment group, right? The 比较实验, right? You just compare, right? Why you do the compare and contrast? Because underlying background is changing as well, right? You have to control them. So that's why you have to take a difference. Okay. And here is a minor point where in the world that this thing can be zero, right? Because sometimes you take the medicine, that guy will have some allergy and then he die, right? So it can be negative. So need not take the medicine can be positive. So that's what this bullet point said. Okay. So so the one thing is called that one is actually this one is something we want to get, okay, ATO, okay, and sometimes we're also interested in this one, okay. It's not the treatment effect, but looking at treatment on the treated, okay. What does that mean? It means that only look at those people, okay, who actually selected to be treated, okay, and we want to see their difference. So basically, what this is general, I don't have conditional here, okay? And later you will see why I care about treatment untreated is looking at how this affecting those people who being into the treatment. Okay, one example with the following, okay? So I'm going to say the example that actually related to also my research. You can imagine it's a problem of looking at how AI affecting people's productivity, right? And the question is, see, okay, you use AI, the other one don't, right? And then you can imagine that the average treatment effect, right? If the AI are assigned it randomly, right? Then there's no problem, right? You can look at those people, the productivity looks at those people have AI, those people don't. There's no problem, okay? The one of the issue usually when you do research is whether people use AI is some selection, right? Even though I give AI, right? And if the guy don't like AI for some reason, then I don't have that. I have a problem, right? Or those people who selected to do it, right? Then there's an issue, right? Usually that's a main thing. So later you will see if the treatment, okay, whether you are treated is random, that's no problem, right? For example, in terms of you have a new medicine, right, for curing cancer, right? If you're able to randomize the patient, right, these people will accept treatment, the other not, then there's no problem. But the problem is sometimes that if some of the rich people, they know the medicine is very useful, they might bribe the doctor some way to accept it, right? Then what you measure is not the compared difference, right? Because rich people tend to be having better characteristic health. So that will be an issue there. So that is, if accepting the treatment is equal, then it's no problem. Otherwise, that you do have an issue there, okay? So the random assignment solve this problem, right? Because if you just do treatment on treat, it will be something like you have AI there, and people may use it or not use it, and you can compare the outcome that people use AI to people don't use AI, right? There's no random assignment. But in that case, the measurement of this is only measurement on trade, right? But because you don't really looking at the people who use the AI is a random misled, right? So that's a main issue there. But sometimes you only care about that. So that's why it's there. Okay. So in order to solve this problem, usually we will have a very useful graphical method called causal map. Later you will see what it is. Very, very direct. It's just arrow and labels. It's just a circle, arrow, and label. So for those you are computer scientists, many of you study the class and you often see this kind of flow chart. So that's not complicated. Don't worry about that. It's called, technically it's called directed acyclic graph. Acyclic means there's no cycle. So there's no cycle, acyclic. Direct means that's the direction. So A to B is not even B to A. Okay. So you can represent this by a matrix. Okay. A matrix of 1 and 0. For example, I mean, let's don't make it more complicated than it needs to be. So this is an example. Okay. So the example of this is, okay, we want to establish causality x cos y. So x right hand in the arrow. Okay. And usually the main problem, we want the regression. You can run y over x, then you solve the problem of prediction. But the problem is, if you want to establish causality, you need to make sure that there's no z at the background, such also affect y, right? In this case, right? Maybe this is not changed due to x, right? Maybe there's something you omit from your model. Okay, so we have to make sure that what you omitted is not there. So we need some theory. So theory will build up this graph, and the graph will tell us your regression is correct or not. Okay, so at the end of the day, we are trying to tell you that when you run the regression, what kind of regression you should run, or what kind of x should be there. What x you omitted, is there a problem or not? So that's the main goal of this chapter. And the next one is trying to tell you what kind of x and y, what kind of x is allowed, and what kind shouldn't be there. Okay? You don't have this problem when you do prediction, right? Whenever it's helpful to predict, then you're there. You don't really care about whether x cos y, y cos x, or so on and so forth. Okay. So there's the map. Now show the map here. Okay. And another thing is called the mechanism. Mechanism M is a oval. Okay. So we say x cos y through mxy. Z cos y through mxz. So this the way that affect. Okay. So you can imagine that what do we say? So maybe, okay, your IQ affect how much you earn, right? But how does IQ affect how much you earn? Maybe more IQ allow you to learn more knowledge. You're more productive, then you earn more, right? So this is your knowledge, right? But sometimes actually you cannot measure knowledge, right? You can only observe maybe you have a degree or not, right? You didn't actually know how much you learn from that, right? Even though I have your GPA, I haven't got A, so what can I do, right? So that's a problem. Okay. So later you will see. I mean, I skip a slide. So the one of the main thing is if everything is random assignment, okay, what you observe in the data has no problem. Okay, suppose you want to see whether medicine is going to make people say health, right? Make people get better, or you have a supplement actually make you healthier, right? As long as you randomly throw your medicine to people, okay, then what you observe is actually the effect that you want to measure. There's no problem, okay? But the problem usually is not the case, right? Because you only observe whether they treated or not treated, right? And this is not the case. So that's a problem, okay? So that is we need to have some very clever way to do it, okay? So that is the main main problem. I mean, we're getting more detail later, but that is the main idea is unless in the medical treatment, right? The medical case is no problem because we pick up a group of patients, we randomly give medicine, right? Not even a doctor knows who has given medicine, right? So in that case, that things become easier, but otherwise can be very, very difficult to measure. Okay. So now we need to understand what, when we want the regression, what you should put in X or not. Okay. When prediction, there's no problem. Okay. But if you want to try to discover the causality, you have to know what to put in X. Okay. So you have to understand what change X. Okay. Actually, there are three definitions. Okay. One is the things only change X. Okay. They call exogenous source. The other one is called endogenous source of X. Is they change both X and Y. Okay. The last one is there is the only variation. But I will let you load the graph, it'll be more clear. Okay. So in this case, okay, Z X change X and X change Y. So this exogenous source, okay, this define X because this exogenous only change X, okay. And usually the problem why we care about this is because we can't observe Z. Okay, so there's something we need to worry about this. And here is I can't see it. If I can see it, then things become very easy. But sometimes we can't really observe. But anyway, this affects the both. Okay, so usually this is usually a problem. Okay, later you will see. If the example, you will see Z1 is not a problem. Z2 will be a big problem. Okay, and as I said, exogenous is good. Okay, the endogenous is bad. Okay, and later we'll see how we're going to use it. And actually, that is what, if later you learn instrumental variable, that's the idea. If in this case, X is a polluted element, right? Because you say X change lead to Y changes, but you cannot rule out Z too. So how usually you do is, because if you're lucky at this guy, then that's good. Because this changes lead to this one. So you can just look at how this and this changes, then you're done. That is the way to establish causality. Okay. And that's is very often that how we understand causal framework is to try to draw this kind of graph, and you will know. But don't worry, I'll go step by step. But this is, I try to hint what you're doing. Okay, what we're doing there. Okay. And what kind of the thing that you have, something like the Z1. Okay. The Z1 is like random experiment. You control the X, right? Because Z, if you do experiment, you're the guy, right? You control it, right? So you switch on the button or you switch off the button, right? Like the IT manager, right? You decide whether the interface of the website. You decide whether to give promotion to the site. You decide to use this protocol at any time, any point of time, right? You can switch on and off, right? You decide to give a premium membership discount, okay? You change it, and then you observe what's going on in the sales or other characteristics you care, right? So you control it, so you have no problem, right? So you're the guy who control it. So Z is the one, is like you, control experiment. The other is something like very often we use is called natural experiment. Is to utilize the fact that actually thing changes is beyond human control. Okay, it happened, and you would able to establish how it changed. Okay, one very famous question, probably you also care, since you pay so much for education, right? And one thing you would wonder is it matter to study for your wage, right? Is it going to spend more time in school? Is going to make more earning? And this is one, I think this probably the first question you learn in people who do research in labor economics. The first, it's called wage regression. This is the important thing, is to start to establish whether study more, right, more school time is going to affect this, right? Your schooling, right? And a lot of problem is like a lot of affecting how much schooling you accept, right? Your parents' income or whatever, right? That's very difficult to establish, right? Your IQ, right? IQ affect how light you like the school, right? If your IQ is not very high, if your IQ is very high, suppose you like to go to school, right? You enjoy doing it, then you have more school, right? And also, if high IQ, you would earn more, right? IQ or something is not observable, right? IQ is something, I mean, IQ can be measured, but how smart you are, right? It's very difficult to measure, right? And how can you do that, right? And there are many, many ways to do it. One very famous way in economics for this is to look at the month of birth. Okay, you can imagine there's a lot of compulsory education, right? You have to go to school until you become 16. Okay, compulsory education. So many places in the world, you have to go to school until you become 16, right? So that means that some people, nevertheless, will not able to spend their high school. They can drop out, right? Because by law, they have to stay in the school. Maybe usually until like the high school, right? End of high school. But if some people is old enough, they can drop out anytime, right? There's some exogenous variation which they can't control, right? That you can check. Or there are a paper talking about education, talking about exogenous variation, like political movement. Like in the old days, I think it's still okay to talk about that. Is paper talk about during the Cultural Revolution, some people just stop their study, right? And they can check how, because just study before, after, then you can see. And also they look at when the university opened after the Cultural Revolution, and then you can see people education changes, right? Or they look at earthquake, right? I think the Sichuan earthquake, some people don't go to school for some of the region, right? As their school closed down, and they look at the impact. I mean, there's a lot of paper looking at those things, and top economic research, that's what they're doing, but they are basically trying to find out this, affect this, but not affect that one, right? You assume that the earthquake is going to change the schooling, but not the income you earn, right? So if you make this assumption, then it will happen, right? I mean, you expect that the day of birth, month of birth, probably will not change your income, right? Depending on the season you're born, then it's not going to change. But that is the idea behind the story there. So basically, a lot of applied economic research, they spend their whole life to look for the nice one. Okay, if you find a nice one, you publish a paper. So that you can see this how important it is to establish the causality here. Okay. So the last way to do it is what we call conditioning, right? It's very simple. You just run regression, you put a bunch of X there, right? Just like in terms of the income equation. Right? We learn the how your schooling affecting your wage, right? But you can also control for the age, which is experience, right? Controlling for your gender, so on and so forth. So that would be the what we call the conditioning. Okay, there are 3 ways to condition. Okay, to help you to solve the problem. Okay. So as I said, this is an example of experimental control, because you control it, so you avoid the problem of other thing, right? And Z is not going to X, right? Z other thing. So you can by controlling Z, regression including Z, you can discover how X affect Y. Okay. So as long as this is controlled by you as an IT manager, right? You control that, right? You control the price, right? Then you can control the sales, right? You can control the output. And as we can see, if it's endogenous, is a problem. Okay. The first one is called the common confounder, which Z affect X and Y. As I mentioned, it's IQ, right? Affect both your schooling and affect your income. Okay. Then the problem is if that's happened, then you have to figure out how to handle them. Okay. And the other one is more difficult, it's even more difficult, it's reverse causality. Right? And in the IQ schooling, maybe you earn more, you go to more school. That's what happened when you talk about M.Phil or D.B.A. Right? The more money you have, you're more likely to get more school. So it's not entirely clear that one way, right? So there's a problem. The other one is what we call unwanted mechanism. Is I want to say X affect Y, okay? But the problem is X can affect Z and Z affect Y. So it's another channel. That's what unwanted mechanism. Okay. Later we will see that when we want to exclude, because we want to say X cause Y, not Z cause Y. If this is the case, Z cause Y. So we need to take it out. So we will see how to take it out. But okay. So this is the graph again. So this is a graph of what we mean by common confounder affecting both, right? And this is another reverse causality, right? I want to say X cause Y, but Y also cause X. That's a problem. Okay? And the other is X affect Y, but also through the confounder. Okay. And then we'll talk about how to solve this kind of problem. Okay. So what we call very often, this is when you always want the regression, okay? In all the seminar, okay? You can always complain this, okay? This is the bingo card. This is universal card. You always complain all the regression is you omit something, okay? And this is very difficult to answer, okay? And how do we solve this problem? Very difficult. Usually I can just try to explain there's something we can't control. We can only tell whether they're biased against us and helping us. But in general, it's very difficult to know what you missed. Right? You can always come up with something that is not there. So we'll talk about this again, but this is the idea that we call omitable bias as a name. Okay. And now we will tell you that very important slide. This tells you that if you want to discover regression, you use regression to discover how X and Y. What are the things that you should not put in X? Okay, so it's different from prediction. Prediction model, machine learning model, right? Whether you put X or not, depend on it reduce the root mean square error, right? There's a metric you know, okay? There's no theory behind, just whether they fit better or not. Here we will tell you that if you want to establish causality, what is good, what this X should be there or not. So here we say these are the three scenarios that you should not put X. Okay, I think I go one by one. Okay, so this graph is better. So this tells you that these are the bad. Okay, if X cause Y there, okay, you want to establish causality. I don't need to put the condition who is changing X. Okay, remember one example. This is like you. If you're experimental, do experiment. You open the guy, right? You switch on off. You don't put yourself in the regression. Okay, you don't need to worry about that. Okay, for example, one example like this, right? Look about the stock market, right? Imagine that the standard case is if you're happy, you're going to buy a stock. Okay, stock price goes up. Okay, this is a standard behavioral thing. And The thing is, you want to say you're happy. Suppose you have some way to measure your happiness, and then you come to the stock price increase. Then one conditioner is like, look at the sky, it's bright. Here we are happy today, right? Because we have sunshine rather than rain. But we want to establish how happy you are at the stock price, right? So we don't need to put a temperature there. Just control the mood. The reason is you want to establish this. When you put this into regression, because it also affects, you didn't capture this directly. So whenever it's not affecting Y, you can simply ignore it. Okay? And if X affect Y pass through a certain thing, okay, you want to establish X to Y, you don't need to put it there. Okay? You don't need to put any intermediate variable. Okay? Because by doing that, you just make it more noisy. So just X and Y, don't put anything in the middle. Okay? And this also bad, okay? It's because X can change Y and the other one. Okay? And you put there, you control it, then there's an issue because this also affect, right? You condition on that, that you would lose a lot of information, right? Because this changes this, right? You include this, then maybe absorb it to there. So because they are positively correlated or negatively correlated, right? When we want the regression, this coefficient can become very small, right? Even though they're related. Okay. So that means that when you draw a graph, when you see this phi scenario, you just don't put it on X, right? Because I guess when you learn regression, you would say one of the thing you learn is like put as many X as you want. You just let the T stat, whether it's more than or less than 0.5 to tell you whether you include it. Okay. That is only because we are doing normal regression. We are not trying to draw causal inference. When you try to do causal inference, whether this caused this, we can't be like put everything we want. Okay, we have to be very selective, very careful. What should be there? What shouldn't be there? Because we want to establish the causality. We want to discover how X affect Y. Okay, we are not going to get the best predictor. If we are going to get how to predict Y, of course, you include this thing. Okay, that is the thing you should do, right? Because even the machine learning may tell you, okay, this is even better to predict. You don't need X. Maybe this is even better to predict Y. You don't have to do that, right? But the thing is, it's not prediction. It's about uncovering how X change Y, right? And of course, IT manager, you sometimes care about that, right? It's a business application, right? If you want to see whether changing the algorithm, changing in the IT system, affecting your output, right? So that is very important, right? Make sure that you don't make the mistake, okay? And it's very difficult to remember so many details. I think the best is look at the graph. Remember the graph, and that's the thing. I mean, sometimes you don't even need to remember the name, right? Just look at the graph. Is the graph is your X follow this kind of pattern? If yes, then should then improve. Okay, I think that is. So I think we finish this. Okay. Now, next is, again, we often talk about this, but the book really like this is often talk about external validity. Okay, I think they keep calling about this. I think there's some reason. Is very often, okay, what we do is either we do control experiment as in the medical research, or natural experiment, usually you do in economics most of the time, and conditional confounder, usually you do it in policy research, because if you don't have money, then it's very difficult, right? And in that case, you are establishing causality within the data you're given, okay, and or within the time period you are working on. But the problem is external validity. How we generalize this, right? How we generalize this based on the past, is it going to affect the future? When you from one market, is it going to affect the other market? Is it going from one country to the other? So I'm not going to, it's very trivial, so I'm not going to talk about more. So I think it's good to look at the example before break. We will try to be very quick here, okay? And the health and food, the first question is you are what you eat, right? You eat what kind of stuff? You eat junk food, then probably your health will not very well. Right? You eat healthy food, then will be good. Okay, so that is what's asking, right? Looking at whether the food affect your health. Very simple, right? But of course, this is very complicated problem. You can imagine there's so many things affecting your health, right? How to establish food is X, your health is Y, establish causality looks crazy, okay? But anyway, we try to do that using US data. This is the description. Look at age or whatever, looking at the blood pressure, right? Is looking at those kind of things, how it affect our blood pressure based on the amount of fruit you eat. Okay, it's very simple, right? So look at the data you have is the blood pressure. Look like this number. I'm not a medical expert, so just some number to us. And there's some how many fruit they eat. Well, surprisingly, there's 0. So I don't know how can someone not eat any fruit or veggie, but anyway, it's there. Okay. So there's data. So this is the diagram that you should think when you try to do causal analysis. You try to do all the, this is the important, you try to draw things, right? You see the positive is positive related, negative related, right? And the question is like so many complicated things, right? And how can you establish this to here, right? And probably based on this, you can see whether you need to control this or not, right? So probably you don't need to control this guy, right? Right? And then the question is whether you control this thing, right? You can tell, right? Based on what we learned, right? The unwanted mechanism, there's collider there, right? You should try to check what are those, right? What is omitted variable, okay? But anyway, let's go directly, okay? So then this is scatter plot and a regression, okay? Now we're not doing any causal analysis, just run the regression simply, okay? And you can see we're comforting, having more fruit, actually lower your blood pressure, which is a good thing, right? Because lower blood pressure means your heart is working better, right? Your artery or the blood vessel is actually not that caught, so your heart did not need to squeeze that heavy, right? That's a good thing, okay? And that is the one that you look at the income, right? The problem is, the first problem you can see is at least in the US, right? Veggie are more expensive than meat. Okay, quite opposite the case in China, I guess. Right? Get a good veggie is more expensive. So likely that you are rich people, you can only afford more veggie and fruit, right? If you are poor people, you can just eat meat. Okay, actually different from the case in China in the old days, right? We say people are poor who eat veggie and people rich who eat meat. But anyway, it's reversed in the US case. Okay. And here we have exercise, right? You can imagine people do exercise actually eat more fruit. Not surprising. Okay. So you can go back to here, right? You have a healthy lifestyle, right? If you are aware of your health, right? You eat more fruit, and actually lead to blood pressure. But you're more healthier, conscious. You are aware of healthy. You have healthier lifestyle. Then you have low blood pressure. Okay. Is that clear? So you're aware that health is important. You will have healthier lifestyle. Of course, you're likely to have low blood pressure, right? But if you are, you have to be healthy, then you also eat veggie more, right? So that's a problem. Okay. Is that clear? Okay. So in the US, is also the junk food, the cheap, right? I probably you don't eat much, but I think in China then would be辣条or something similar, right? And the question is, right?辣条, potato chips and vegetable are negative related, right? The more you take, then you take the other one less, right? So there is a negative item. Okay. So so you can see that this is the established the negative, positive one. We will talk about how to do it more carefully the next topic. So we'll talk about how actually run the regression, but this is just to give you, try to draw this map, okay? Once with this map, then you can tell the next topic, what should be there, what shouldn't be there. We'll talk about this after the break, okay? In the meantime, the break, I would also release the quiz 4, which is the last quiz you may do. If you already score full mark for the first 3, you just attempt, you got the full mark, right? Because if you more than half, you get 3. Okay, 3 times 3 is 9. So the last one, if you do nothing, you still get the full score from that. But anyway, so I would put it there. But it's not formally released that it's there. So if you already get full mark from the first 3, the last one you just submit, then you get everything. Okay, you just submit. Okay. Yeah, quiz 4 is there. I think 8 question. And you get right 4 or more, then you get full credit. Okay, multiple choice. So we will resume at half an hour later. One. I continue to have my own beauty. Anyone want this? I'm the first one. 最好钱，这个莆田小红，谢谢。香港加飲香港奶茶，Hong Kong style。对对。我新加坡也吹牛。新加坡车很贵啊，中车证啊，和私有的。中车跟新加坡哪一个车很贵？啊，这个车很贵。我说那个开那个车，那汽车。对，不要钱。你得在公积金嘛。怎么没有啊？这个车的车牌要10万大了。10万新呢？60多万给我，这个车而已。就是车的
license，所以不是这样。还没买车，买车的话还要拿多差不多1倍的钱，差不多100万才一个车。哇，哪里有这么多钱？
你怎么没有这么多钱啊？
没有啊，很穷啊，老是穷。
真的假的？
真的真的。
我觉得香港这边教授1年也至少100来。
老师商学院的教授，怎么会这么穷？
因为我的同事有的很穷，没有办法。我是经济学家嘛。
经济学家可以理解，可以理解。
对，我同事应该挺有钱。他们就说我们学院
都很有
啊，
你的同事都很有钱。
有些几个大老板，他们真的大老板是的，大。比如说那个做什么商汤那个
他们说 professor， 就是或者是你说 professor， 也是外面还有政治，或者是
经济是不可以的，但可以做大了 ，under their approval。OK， 太麻烦了，我们是不能随便进去的。
给人当很高的，
对，也是有批的嘛，有东西。也是。
是什么整点外派了？
是啊，但是
奶茶以后就可以升级了啦。
给你山东打分。现在离婚了对吗？他们离婚了。奶茶那边还没离婚。
没有吗？
没有吗？离了
吧？
离了吧？离了吧？
我记得好像我记得看的那个。
我也知道哦，这样。
好像觉得。
啊，查一下。
所以大家的
地又不一样。
所以大家
不关心这个
啊，
大家不关注这个。
对于我这个客商换奶茶的，很单纯。
是个还行。
当这个张德确实结婚好没，好像还没。
没有吗？
真的，我觉得他们有关。
婚后好像还没看到。
哦，没有。OK。
那一直以为从他当时搞跟美国搞那事情还有不会。对啊。
你都可以办走。是拿了一半放自己的，
本来结婚的时候就已经把那个地产已经完成了，把10年的工资都已经提前拿出来了。
这样啊。
他就是跟那个金工说，我10年之后的工资结婚前提前就已经提出来了。
好，然后就做公证，
对，公证都有财产的东西。
啊，
太厉害了，高手。因为中国是没有这个什么只有一个分钱产生，在市场是没有用的，他怎么干都没有用。
香港就是
工作对半分，不止看谁负责，在上头看多。
我没有搞过理解。
我搞经济学的吗？怎么分割财产是我研究的问题啊？怎么研究分割的？我研究怎么分割东西，分割财产，分割钱的研究的问题。
那他们也会律师，是法律，但是你也有保证。
法律不止跟你说了，法律这边，香港法律很简单，
很简单，
就是国安来判的，看你什么。很简单。
我不问啊，我对我上面同事
他是在学的，
对，但他就分部来做回顾，但是这一个他就研究，
他不是在的话，他在我们开始说现在可以了。
哦，他只是说他
是大学，
这样跑这样可能是这个对这个有，
但是你可以根据我们刚才说的理论，你可以告诉我，我应该放在 A 角，应该放，应该怎么说？就是说 A 是应该放，
类似的方法，
可以这个学嘛，因为它是
这个做那个。不知道这个办行业叫要的不做，做中介 介效应有点
无法定学的话，就让你不要上本
就是说 x 它如果是这种 x 对外影响的话 ，x 也和这个太阳影响的很大的，对吧？或者如果有这种从 x 对外影响的话 ，x 通过这个，比如说自己
拿教这个environment，对，拿教要看这 environment。是的，对，你要这办法。
现在大家对这个就是这个中介效应跟调节效应，现在用的这种
这个他们说这个是我知道这个有要搞动的人可以说一起的老师。
就说现在这个英文推断说用这个两种方法以后，就是不好判断。
但这个是一个很大的一个。
那不是烂掉。
对啊，
很多的
但是就现在有没有什么新的方法去做这个英文推断法？就看就还是那个
方法没有，
还是3步法，
都会这样。不是，
就是3步法。
free stage 后面的都是基本上都是会3步2步或者3个节3步。但很多学校都是一步做完。
一步怎么做？
下里直接问。我讲的这个是单的在玩，我还是在玩，然后这个 boss 都在单的。
我之前是做那个效应啊，
对不对？那个 policy 对啊，就是那个是也很少了，但是 policy 我open 的policy 多人多，这捞钱。
我觉得追逐的话，就是说你 x 到 y， 它其实是相关性有很多文章都是我 x 到 y 也可以 ，y 到 x 也可以，然后它
这是 IBM。
不是说你
IB 也很难找。
那 IB 的话，你找对啊，就找 IB 的那个。
就是我们做这个是先有理论，先发现和这出来，对，现在很高出来，因为现在不一定的东西在做这个里面，所以说对教育的地方化，对很多钱就多点。就是你会这个问题很重要的 ，accept 这个观点。为什么你说吃药的话，为什么我真的去做那么出来？
吃药这个感觉还可以理解，
但是你做。
理论上，我就是方法说，高射炮导的。
对啊，对的，是
你直觉上你就知道它应该是这样的，然后你要用很多那种方法去验证，但我觉得没有得出这种
没有对的那个
对啊，而且它到现在我看之前做的时候，人家数没接受，我大家都是找了1个星期，找完星期之后反正就是有这样的影响，但是它的数据没办法解释。就是比如说，按道理我应该我用了这么精确的推断方法，我应该能说这个100%不会影响到我的结果。但是那个数据现在基本上
有不是大概是不要担心，
大家只能说就只能说影响。而且会生气呢，什么移动病根本没法解，搞不完你就不能修的。
所以 data 就是拉不去上面，
所以我觉得是，其实我对那个就是怎么说，既然我做不了精确的那个模型，那不如跳过最简单的那个。
对，我也是，对啊，对。所以我来做一个 OS 的，在 OS 的要求我们没有，所以 OS I 已经很难。 好来组织这几个都得做。和 B.I.D
对 B.I.D 确实比较感觉比较直观。
B.I.D 我们之前我讲一下，
看个图就很难讲。
不是我知道的，但是要报数据。
还有这个反应 B.I.D 上。
B.I.D 之前之后两个模型写出来。
啊，是你之后吗？
多期 B.I.D。不是，我就说你把之前之后的两个 line 写出来，模型写出来，很好理解。
来 B.I.D 还是比较好出来。我是在广西这个电火电，就是打五种的类。
所以我觉得是要很大的区别。
打完经过一个。新的话，你们叫 factual estimation， 也是一个地方的，还可以做。你好时候现在结构工程要每一次，那很多时候可以见到的。来什么？因为为什么？
推荐系统，那个感觉跟经济学不是一个领域。
那这个都对都在为的，那这个它可以是看到，我也不说这个还不大对，那个跟某个对，现在看什么一点那个样，是的。
推荐系统很厉害。
说了一种，但是我现在搞不懂。
哎，你第九吧，第九是。对啊，我只要觉得这个东西比较好，很大的钱，我们很伟大的系统，
做理论提出新的。
对啊，就是对啊，我的钱这么小就捡起来，还想让我做很多大部分。你给我多点钱，我多点贡献，钱我就去满足我的生产力，就是我生产力就根据我的工作量的。我对得起我的工资，
这节课学到这个就够了。
对吧？所以我
这就是 life belief。
老几多了，你有爱输爱尔，
没有升
啊？
没有别的非常
用领导啦，
有買除冇買可以。
我都不是不好看，很简单感。
对啊，对，gold 可以啊，marginal，那经济学去教有trade off 吗？trade off 吗？marginal benefit，marginal cost， 对吧？所以我觉得教完你们就把重要的重点把它教完就可以。我们填一下吧。对，哪一分都拿了。我们
哪一分啊？哪一分？你说哪一分就哪一分。
哪一分submit就有1分了吗？为什么不按submit就1分钟？就1秒钟的事情 submit 一下吧。你拿submit就有1分啊，反正你都肯定前面都拿够了。啊？看了。看了。
这个题目真的做了啊。
Try to fill, even though you got full mark from the free, you submit, you get 1 point, okay? Just submit. At least you submit, okay?
想喝就喝一下。Come again. 正常我不把我的设备交给我的，我这个团队团队。最近哪几个比较别的给不要每次都看到我怎么都要给单的时候，我会有一句话就是说，我们不要给单的时候，我放在我们不是拿来谈的，都在我会谈的。我老婆在做都不能我呀，就发更多係但我可以正常都會打翻去。如果唔做老師咁我就唔可能識嘅，唔係我唔想答，可能唔識答。我淨係識答我識嘅嘢咯，我唔識嘅就識答我。呢啲先係拍牌嘅，還有啲人所以我就好中意聽佢同飛點解點樣互相對啲方面。雙方嘅咯，雙方嘅我跟大家，即係因為我比較大，大家知道我。你又話你教會科都得閒，相對我就點講？要開會，我比較少問題。大家唔係點樣？大家唔係佢最後都知道，即係一路搞出嚟。三粒可以揾錢㗎，賣錢得㗎啦，唔俾。O K， 做嗰個價值係出去。咁啊係，好多濕嘢㗎嘛。唔係好似你出產㗎嘛。點解話啲人之後少少之後，即係嗰啲 case。嗱，你大知有個超大，然後嗰次，咁後來嗰次做咗佢差咗佢好自己出糧幫啦。咁但係你做到賣呢個俾錢你，咁你賣你都要分翻俾佢睇啊。咁但係佢出咗糧俾你咯，咁你冚好心一點都冇人要，而家佢一冇本生意，買得啲好新，你話買啲食第一個。係喎，執咗又唔使，執到嗰陣時執嘢喺度，都得啦，有白間真係。咁咪要孭住燒嘅，如果我俾佢買個資嘅哇，有錢啊！即係咁你做你有雙方都係咁啦，我哋成功咗一間就夠啦，成個其實好多嘅，好多你唔識嘅，即係行內點識啫？都你知嘅，你識佢係即係比較夠賺啊，就嚟。呢個微分咯，我都不微多就一分啊。對啊，一個 population 係 population 係一個 data， 然後喂，但係 bootstrap data 得到一個好啲嘅方法，你個 data 可唔可以？咁你就 test 但係個 data 去翻我覺得即係做一個。我即係 bootstrap 其實咩係 bootstrap 只係話有 sample data、sample 即係一齊 data， 很多个 data 都需要考虑到每一个 data 都需要有一个分区 random 为什么都稍微不会做的 next time 的快的？是不会考虑的。
我都覺得點樣我中係我唔係好明會出啲咩，即係你 return output 就因為要大家考慮三個。
咁都係正常嘅長啦。講點我哋你頭先咪俾派上歐配啊？主要係派這個派歐配啊，對咪對？話開人話大，可能對人家所講嘅安排都唔要，但係啱幫夠。想睇過泰國歐配嘅報紙，佢就係我最緊要講。我哋個 management policy 俾個係嗰個 alpha 係冇用 base x 有。有個 alpha 解釋嘅 alpha 即係意思係 alpha。但係點樣用？我點用啊？你 alpha。我想問下你做對盤，即係對盤計嘅，唔會特登去問下呢個同我覺得特別即係譬如我 x intercept 又或者譬如嗰個 beta one 係話叫 x 係冇用。咁alpha 我alpha 即係我即係主要考慮呢個實際嘅因為啲哦，俾你3哦，要3啲唔同 undergrad 考計數你大概知考我準備下。準備下。而家就係個問題。
So if you done, then please submit, and then we go on. During the break, some of you worry about the final test, what it looks like. Yeah. Yeah. Some of people. And I want to emphasize our class is apply. Okay. So I'm not going to ask you some theory problem, but mainly the apply. So the main thing, of course, I ask some theory, but the main thing is try to ask you is I give you the Python or computer output. I want you to ask a question based on the output. You need to tell me what is what. Okay. That, I mean, you can see the slide there. It should be sufficient for most purpose. And I will try to give some sample question so you know the style I'm asking. Okay. I hope, yeah, I'll try to do that later. Okay. So let's quickly finish this. So for this one is regression and matching. Okay. So I can say safely this chapter is so complicated. Okay. I don't think I have, even I study long time, I'm not sure that I fully understand what's going on. Except I know how to run this kind of regression. So, but the idea is not super complicated. So the thing is like here, I try to be more internal conceptual framework, not really go into detail because even you try to look at the code, it's not that easy to run. So I'm not going to, I just telling you what's going on there. Okay, just be very brief because I don't want, because I doubt any of you would actually do that. Okay, but I just have to tell you what's going on. So the idea is the following. Okay, if we have the data that come from experiment, right? You don't have problem. Okay, the main problem comes from the data where you observational. That's why it can be anything. Okay, so we call what we learn is if our data, okay, is exogenous source of variation, you shouldn't do it. If endogenous, then you should control them, right? That is the main idea, okay? And so when you run this is what we learned before the break, okay? So if you run the regression, what should be put in X? You have the good thing and the bad thing, okay? Make sure that you don't put the bad thing, okay? And that is it, okay? And that is the tool that we do is the controlling confine, as I said, right? We say we try to control them, okay? And there's another two way to do it. It's called the matching problem, okay? So the main problem we talk about here is it's not random allocation who got treated or who not treated, okay? So the problem of control group is an issue, right? Because in general medical tests, right? Those people who receive treatment or not receive treatment is randomly assigned, right? But when optional data, you don't have this kind of luxury, okay? So you have to figure out how to got what is the benchmark, okay? So that is what we call this kind of matching method, okay? So I try to be very brief here because I don't want to go to detail, because one of the reasons why I don't want to go to detail is some people said, I don't know whether it's true, that if you got the matching, you can get any result you want, depending on how you match. Okay, some people agree if you do it. So that means that it's not a stable method. So far, we don't have a good idea how to do those. So that's why, since it's not very stable, so I'm worried about how useful are this knowledge they are. Okay, and that being said means that if you really want to use this kind of method, you need to do many robustness tests and many kind of things to establish your answer is stable. And I guess it's way beyond our level, right? If we are able to do that, then you're a PhD student. Okay, so in that case, it's not very useful for you, but I still want to introduce them, at least you know when you see them what they are talking about. So basically this is more conceptual. So if you're very tired, which many of you are, you can take a rest a little bit because really conceptual thing. Okay, so you don't lose. If you lost a little bit, it doesn't, you will not affect too much. Okay. So as we have the thought experiment, it's very important. Okay, and usually you look at the textbook talk about causality or causal exercise. Usually they will ask you one thing. If I want to say how X affect Y, okay, you would think of an ideal experiment that you are able to have so much budget, you have so administrative power, you can think how to check how X cause Y. And that's ideal experiment, okay? And from the ideal case, you can see how the real world departure from what you think, okay? So let me be clear here, okay? So here we do a thought experiment, okay? This is interesting thing you want to do in finance or accounting or economics, is we want to see whether family ownership actually change the management quality, right? Is it the family own the firm going to be better or less, right? It's a very simple question. right? It's a very common question in the Asia context, because Asia, you tend to have more family ownership compared to the Western world, okay? Especially when we look at Korea, Japan, basically many of them are family ownership, right? Look at the Nintendo, right? They are more than 100 years old, right? Or many company actually last very long time. So the question is whether this is going to make a difference, okay? So what is the ideal experiment? Ideal experiment is the following, right? So you would be, what is, I just want to see it, okay? Oh, I forgot to share the screen, I guess. So you would be looking at this is, I have a bunch of company, okay? I randomly tell them, you are family owned, you are not, okay? Suppose you can do that, okay? Then you can measure after a few years, see how the management change, right? That is the most ideal case, right? Bunch of company, and then you change the ownership, right? And this is what it said, right? That look at the average, okay? And okay, so that is the ideal thing, but I skipping the detail, but because it's not very important, but already know how you can do it, okay? But the problem is whether firm being family owned or not actually is a selection, right? If the company owner think the company is good, they will keep by themselves, right? If the company expected to go bad, they go to public and give it to you, right? That's usually what we call the corporate finance theory, right? It's just like good thing you keep in your pocket, right? Good thing share with us. Bad thing you share with others, right? Just reverse the case, right? So so that in the real world, that the choice of family ownership is actually endogenous, right? It's the thing that is actually predicting how good the company is, right? So you can imagine family-owned firm, likely you observe in the real world, might be a better owner, can be, right? Because if the better owner, they keep it themselves, right? If they're poorly owned, they should basically go public and you get it, right? So that's the idea. So remember, these are the variable that you should condition on, and these you shouldn't, right? And this is we talked about last time already. Okay. So the method, as we said, is the way is you think about the ideal experiment. Once you do it, you do a DAG, is the graph. Okay. See what is good to condition, what is not. And you try to estimate ATE. Okay. If not, you get ATET, okay, treatment on the treat. And very often it's very difficult to observe that. So the only thing is probably is ATET. Okay. So the example like this, okay. So you have a bunch of data, many firms, okay. It's consumption data, right? At the same time, you go to many firms in manufacturing in 21 countries. You look at the management score. You want to check whether family-owned firm is better. Very simple question, right? This is the Y, the score. X is the ownership. Very simple question, right? X cos Y. Okay. And you have to figure out what is the causal map. Let's check it out. Okay. Okay, this is the graph. Okay. So you want to establish ownership of this, right? They figure out that there are many things there. That's the graph they draw, and then there's something you should draw it. And some people said, what is user economics? What is user theory? Theory tell you this. Okay, this the theory allow us to draw this graph and allow us to sign this kind of crazy thing, right? That's what the theory use. Is that clear? How you get this? Okay, theory tells you this. Otherwise, you cannot have that. Okay. So this is the main goal we're gonna do. So let's go back to before. So we go one by one. So first, family circumstances. Okay. You can imagine that whether family, that big family or small family, family harmonized or not, right, would unlikely affect this management, right? Because it's managed by the owner. Okay. In that case, the question is, should you conditional on that? Yes or no? Yes or no? No one try to answer me. Okay. So it's exogenous variation of X. Should you control it? No. Okay. If you forget, go back to here. Right? Exogenous variation are bad controllers. So if you want to discover from here to here, you don't need to look at whether the family, they fight each other, whether the owner have multiple wives, right? Whether his affairs, we don't need to worry about this, right? Whether he has how many hidden son, how many daughter, we don't worry about that. Okay? There's not an issue there. Okay? Second, competition. Okay? Do we need to worry about the competition of the firm? Okay? What it is? It's affecting the both. Okay? There's common confounder. Go back to the slide. Okay? Do you want to control that? Common cause. Do you want to control it? Yes. Right? You control that. Okay? And same for the rest. I'm not going to one by one because I think that you should go back and forth and check. Okay, is that clear? What you should control X, you shouldn't. Okay? And probably some of you say, why I become economist, what's the use of me in this, right? As an economist, I know how to draw this, right? And I can come up with the side, right? Although I don't know this, but from theory I learn, or you can read the literature, you can establish this, and the rest is you can decide what should be there. Okay? So that is the use of theory, as some of you would question why you learn theory. That is the reason why you learn theory. Okay? And without theory, how can you draw this kind of picture, right? There must be theory to say this doesn't affect this directly, right? So they tell you not to control or to control, but the answer is there already. So fine, I'm not going to one by one. Okay? Now, okay. Now you know what is put in X, right? What you should control, you know it, okay? And if you simply run this regression, okay, you can always, if you control everything you want to control, which is never possible, but you're supposed to do it, you're done. Okay? And if there's nothing is omitted, okay, everything is fine, then you're done. Right? Of course, you would always wonder this is valid or not, but usually that's what we do, what we got. Okay? Is that clear? So if you are able to say what you omit is not there, it's fine, everything is fine, then it's fine. So there's no need to worry about this. You run the regression. Okay? And the other way around is not to run regression. Okay? Regression is the way to control the Z. Right? And the other way is to not run the regression. You just take a difference. Okay? So what does that mean? Remember, Z's are some characteristic or some of the factor you want to control, right? And if these control are finite or discrete, you can easily control them, right? For example, I talk about medicine case, right? I can only take a difference between male, right? Then I can do the difference, right? You can look at all the males and all the females, right? Or the old people and young people. I just compare the control group and the non-control group. I always look at the male difference. Then I can measure that, right? I only make sure that when I make a difference, all the characteristics I comparing, the control group and treatment group, are coming the same thing, right? So that is called matching. So it basically just like I have, say, I suppose what to do the following is, I don't do regression. I instead I look at, okay, a patient, okay, I give him a medicine. I know he's a male, he's old, he get married, okay? Then I look at another guy, he's also a male, married, and old, but who took the medicine. I take a difference, okay? I'm not on the regression. I just match directly. Who is your treatment group? Okay, so basically, for every guy, he has the treatment group. Okay, maybe just one or multiple, but that is what it means. Okay, it's not one regression, but I just simply take a difference between them. Is that clear? Is that okay? Okay, so not one regression. Okay, how to do it is very complicated. I don't even want to talk about that. Okay, and exact matching means you can exactly match because the characteristic is I have data is rich enough. Everyone, okay, I have the counterpart I can match. Okay, but in general, you can't have this kind of nice thing because your variable is continuous, right? When your variable is continuous, like age, right? When some guy is 50 years old and 54 days, and then how can you match that, right? So that's why we'll use the Carson match, okay? And how do you do this match? Is we didn't cover that. It's called sometimes you use the nearest neighborhood. We don't talk about that, but the idea is the following. I draw a picture. It's look, you can imagine you can imagine a scatter plot. Okay. Suppose I have a data. Okay. I have two feature, right? X1, X2, and suppose this is data which is treated, right? And how can I look at the cases? I look at other untreated variable. Something like this, right? Suppose this guy take the medicine, right? With this feature X1, X2, maybe X1 you can imagine it's age, X2, say X1 is age, right? X2 maybe just wealth, I don't know, right? And if exact match, then you have to find the exact guy, right? Exact match would be just I'm looking at the counterfactual exactly here, right? But in general, you don't have this, right? Because age is continuous, very difficult. So what you're going to do is, where's the color? Okay. The way to do is, you will find the nearest neighborhood. In a sense, you draw a radius, right? Suppose you would draw a radius. This consider nearby, right? And you pick this 4, average of 4 will be its control group. Okay. So this is Carson exact matching. Okay. I just mentioned it how you do it, but as you can see, right? As I said, you can get whatever thing you want if you try to draw a different way. So it's a very, I don't know, you have to be very honest in order to get the right thing. If you're cheating, then you can cheat easily. Okay, and some of the experts here know very well. The other way to do it is called the propensity score matching. Okay, that one I'm not going to go to detail, but instead of looking at where you are close in terms of the Z, you would run a logic or probit. Okay, logic and probit decide whether you get treated or not. Okay, whether you get treatment depend on your characteristic. Okay, then when you run the logic, okay, run the logic, right? Logic or probit. Okay, and then you decide whether you should be in the control group or in the treatment group. Okay, so that is the idea. You run it. Okay, so that is the theorem behind, because even to give the formula is very complicated. Okay, so I just give you how to do it in Python. Okay, so the way to do is we have, there is another library. Okay, I doubt you use it, but I just put it here. It's called the causal library. Causal library, estimation, proportional score matching. And the other one is called inverse probability weighting, which I'll talk about later. Okay, and you have a logistic regression, right, to determine whether the PS score. Okay, and tender as a PD. Okay, and I have data here. Okay, the data here, you have treatment, you have some Z, right? So this is X, and this is Y, and this is Z1 and Z2, right? So this is the data. Is that clear what we're doing? Okay, I append the data frame, so nothing new here. Okay, nothing special, but just know some package here. Okay, and you can see here it's not complicated. Here I define what's X, what's treatment, what's Y. Okay, and here comes the magic part, is computer do everything. Okay, computer do it. You use proportional score matching. Okay, the way to do is logistic regression. You can do probit or other thing, but logistic is the easiest one. And solve by linear model. They saw a balance. Again, you can just do this thing. I mean, you don't need to worry. And this is called the proportional score fit the model X, treatment, and Y. This is the standard. And once you do it, you will use the proportional score match to based on your X and treatment to predict the outcome. Okay, that's to predict whether you are in 0 or 1, right? And you take a difference, that is the ATE, estimated effect. So this come up with the ATE, right? Then can tell you whether you can, how the treatment change your Y, right? So basically what at the end doing, right? Remember what we're doing here. The data is this outcome, right? You want to see whether the treatment 0 or 1 change the outcome by controlling the covariate 1 and 2. So remember that's a goal. Okay, the goal, again, I repeat, is look at whether the treatment changes affect your outcome, right? But you want to control this, right? But to control this is the way to do it is like comparing. You have to find the comparison, right? What's the benchmark? Okay, and the way to do is proportional score matching, right? To match whether you are actually 1 or 0, right? Because for each observation, you only observe their treat or not treat, right? You figure out that the case where they are not, right? So potential outcome. Okay. So you match what? Okay. So don't worry if you don't fully get it, because it's very difficult to understand. And for my research, I never use this. Okay, because as I said, many people complain about this methodology. So I never use this. But I will just put there what you can see here is, okay, remember the management story, okay? What is said turned out to be, okay? Compare the case where you have the score of family-owned firm, okay, and non-owned one, okay? Family-owned firm has lower score, okay? Just the raw data, okay? Okay. But so this is the answer. Okay, so they use the PSM to do it. I remember correctly. Okay, so if you let the firm go private, go to the not family ownership, go to public, then actually the score will increase. Okay, so it does suggest that family-owned firm actually is not as efficient. Okay, so that is what he said in terms of management. And okay, so that is the regression result. Okay, so if you don't have, but that is without co-founder. If you control the Z, actually it's much less. Okay, only little less, right? 20%, 0.2 before it's 0.4. Okay, so that means that family firm is not that bad. Okay, although it appears pretty bad in terms of quality, 0.73, right? But now it's just 0.2, just 10% less rather than 20%. Okay, so basically, why you can see the drop is because of the different characteristic of the family-owned firm and other firm. Okay, so if you don't control, that is might not make a difference. Okay, and the question you ask is, we do regression or we do matching? Okay, the answer is usually they're the same if your data is rich enough, right? It's enough X there, there's no problem. The main problem when you need to do matching is the data there's no comparison, is not very rich, right? Because you control the thing. So you need to figure out how to make the good control group. Okay, so is it better? I don't know. In general, if they don't agree, the regression result is not same as the matching result, usually you would not take it, right? You have to take the one that they have common result. So usually what we say is you would only do matching only if you do the regression, you get the right result. And then you want to do the matching to confirm you're doing the right thing. So it's more like the robustness test if I were to use it. So that's why we don't need to worry too much about it, right? If you only get the result from matching, I would not trust it. Okay, so usually that is the usual take. That's not me, but usually look at the literature, it's like people think in this way. Okay, so before the break, I want to talk about two methods, okay, that commonly used to solve the problem of what we call omitted variable bias, and these two are better than matching, I would say, way better than matching. Okay, or we will just have a very rough idea on that. Okay, this is what we call instrumental variable approach. It's very important. Is X and Y. Okay, we want to measure X, how X affect Y, but again, you have some omitted bias or confounder. It's very difficult to solve the problem, right? And how do we solve this? Okay, let me give a picture. No picture here. So the idea is like this. Okay. The question is, what happened when you have more than 2 kids, right? Actually, kids affect the earning in the family, okay? And usually when you have 2 kids of the same gender, 2 boys or 2 girls, usually you stop, right? You don't want 3 boys. I mean, ask the ladies in here, right? 3 boys very naughty, right? 3 girls will be very troublesome, right? I mean, feel the same, right? I mean, if you're 1 boy and 1 girl, usually you might continue, right? So that is the standard thing. So that's why if you have 2 boys, okay, usually you will stop of having another kid, right? But having boys is exogenous, right? The gender cannot be chosen, right? Then this, right, is helpful, okay, to help us to do the prediction, right? Because they're the same gender is not controlled by you, right? There's no choice there, okay? And this is exogenous variation, right? Having the same gender doesn't affect Y directly, right? So remember the IV requirement is it affect X, okay, not affect Y, right? Because Y is important, right? How much you got paid affecting how many you have your kid, right? Your kid how many paid. So it's a reverse causality here, right? The problem is, right? But if you're able to control the gender, right, that is, then you have no problem. So let me repeat this because I want to make it very clear. So what you want to do is number of kids, right? And how does it affect the kid is more than 2, right? How it affect your earning money, right? This is X and this is Y, right? And there are many issues here, right? Because if you have money, then you have more kids, right? Look at Elon Musk. How many kids does he have? Right? 10, right? And how many kids does I have? 2, right? Because I'm poor, right? And you can look at this comparison, right? More money gives you more kids, right? So then how can you solve this problem, right? Is it more kids actually make it worse off? Is to control the gender of 2 kids, okay? If the 2 kids is the same gender, usually people would tend to not to have further kid, right? So that's why you have a Z, which affect this and affect here, but there's nothing this one, right? And the gender is not affected by, it's nothing control. It's the God, the nature decide, right? So in that case, you can use this as an IV. Okay, that's called instrumental variable. Instead of X, you regress. There's some way to regress this to uncover it. Okay, and I just tell you how to do it. It's called the two-stage regression. I'm not going to go to detail, and there's a certain way to do it. You run this kind of regression, but I'm not going to talk about that. Yeah, but this is the way to do it, okay? And I just take 5 minutes more. So the next one is called regression discontinuity, okay? The way to do it is very simple, but it's a very specific setting, okay? The specific setting is very simple. Many of you go through Gaokao. I think everyone go through Gaokao, right? And you will notice there's your I don't know, 高考成績, right? There's a point that cut off, right? Above that you enter, below that you don't, right? Then look at that score, above and below, you think they're similar, right? And if you're above this score, maybe you go to top 2, below that you don't, right? Then you can see whether going to top 2 make a difference in your life, right? Because you look at the exactly nearby, or it may make a difference, right? So that is usually what is being done in regression discontinuity, is exploiting the fact that people nearby the threshold, nearby a certain value, they are very similar, but there's some exogenous mechanism that breaks down this, okay? And that makes a difference, right? Just like in many cases, not in China, but in many cases we have an honors program for undergraduate, all right? So if you get GPA more than 3.6, then you automatically become a first honor, right? And if you're below, there's not, right? At least as I know Singapore like this, right? 3 point something. And the problem is, will the honor actually help you to get a better job, get a better salary? But indeed, in Singapore, it's like this. It's very clear. You get the first honor is much higher than the second honor. But how do you estimate this in the data? Is look at the people who actually got just into the first honor. So look at the people who, how much they earn if the GPA is 3.6, 3.61, 3.62, and compare with those who just missed the deadline, just missed the line. Look at those who get a GPA is 3.59, 3.58, 3.57 who just missed that. Then the difference between them is the effect of getting an honor. Is that clear how it's being done? Okay. Of course, it's very specific thing, but this is how this thing being done. But as I said in the slide, everything is technical, so I don't want to bother you with that. Okay. If you those who know, you run a two-stage regression and you do 2 times OLS. But I'm not going to bother you with that because I doubt any one of you would ever use it anyway. Okay, but you will be reading some of the paper that use it, then probably you understand. So it's not that you use it, but you will try to understand what people have been done. That is important. So at least you know what's IV, right? You don't really worry about how they get the regression, but at least you know what are they. And same for regression discontinuity is looking at there's some variable, okay, that decide your fate, and then you look at the cutoff there, cutoff before and after, how they perform, right? And then you can see the treatment is going to make a difference. Is that clear? Of course, they're all extensions, so that's why I'm very brief. Is just because you didn't even mention in the textbook. Okay, there's a mention this something. I just being brief on that. Okay, so let's have a 15 minutes break. After the break, we will skim over lesson 10. Okay, don't worry. Just skim over. Okay. In the meantime, we do allow you reply.
Oh， 唔係個 control 嘅意思係話，譬如話你譬如 GPA 3.6啦，咁你咪有一堆人睇個煙頭嘅時候，咁你睇呢度嘅人，呢度嘅 evidence， 咁咪俾煙頭呢個叫 control。呢個係 GPA 嘅叫做 running rate control 嘅 running rate。 control 咁即係佢 control 佢咁樣嘅咧，呢個就係 control 呢個全部你唔需要，你啲係有啲㗎啦，呢啲下邊嗰個係 chip， 下邊嗰個 control， 而家我俾 control 啦，你假設高啲係高啲你就有個 top， 高啲就有 first on 唔係 control， 咪 treatment 就 control。唔係睇你嗰個 treatment 係咩？其實 treatment 就係你嗰個 treatment 就係你攞 first on， 咁咪 first on 就係 treatment。唔係你 treatment 同 control 睇你個問題咩嘛？唔係你講緊冇 first on 同埋有 first on， 你可以睇。
但係點解嗰個 AT 嘢減唔係加嘅？
唔係你要減咩講 difference 咯 ？AT 咪就係話你有 first on 同冇 first on。咁如果加咗咁點 difference？AT、ET 咧 ？ATT 就係話呢度嘅人 ，ATT 就話我唔 care 你個 difference， 我只係問如果呢堆人佢有你個 first on 佢，即係唔係 first on 佢，
即係佢就咁係嗰個 expected value 喎，Y1。
係啊，咪但係最主要你唔會直接 measure 到，因為主要係話你有你而家呢度你嗰個係 random selection。咁所以如果係
random selection 係 based on，
即係譬如你呢度係呢度你假設我呢度 cut 係隨啲嘅，咁所以 random selection 即係佢因為佢假設話你呢度係 random， 即係佢個細，所以佢就係所以佢 measure 到佢個 causal impact 啦。即係最大嘅問題 AT 同 ET 嘅 ATT 嘅話 ，ATT 嘅話就係話你嘅 control group 同埋個 control group 同埋嗰個 treatment group 唔係 randomly assign， 最大嘅問題。 頭先我講話，譬如話我用 我咁大家啦，個 AI 俾你嗰個，你我繼續，譬如話我而家試下 AI 幾有效，咁我睇下你自己做嘅嘢，你未俾 AI 之前你做嘅嘢做得好唔好？你俾 AI 之後做成點？咁我個 difference 係咪出問題出？因為但係點解呢個有問題咧？就係因為你去用 AI 嗰陣時，你自己想用 AI，咁你覺得 AI 用咁呢個唔係 random assign 咯？
唔係 random assign，
即係譬如你個 AI 度，我隨意俾人，咁呢個冇問題。咁但係擺 AI 度咧，你攞嚟用，你 improve 咗。咁我唔知你呢個嘢係咪包含你攞嚟自己做嘢有關嘅？因為你覺得有用先攞嚟嘅啫。咁所以可能呢個嘢點樣做嘅？如果 random 啲 assign 俾你，你 AI 佢唔可以用，咁就唔知。
但如果同一個 observation，佢又有變係咁就。
唔知佢有冇 selection， 即係話你去選擇我嘅 treatment 咧就唔得，有冇 selection？ 對 selection 即係呢個問題，即係嗰陣時係咪如果 random assign， 我俾你係我擺喺度，你去做，喺你前後，或者你聽到我傳，跟住睇到你未講之前係啲乜，之後做啲乜，咁咪唔對。
呢個係嗰個 observation 之前，
係啊，
但係你就唔解係
係啊，我係咪都係 measure 嘅 average effect 㗎嘛？我唔係 measure 咁嘅。如果做緊咩嗰個就到 DI 對嘅。DI 對。呢個單人呢啲單人就做呢個。
我刚刚说就是打完那个 X， 我觉得第一个然后他问这里是为什么波这个什么，这个是一款就是因为这里不应该
哦，你先在那边。哦，
所以是单纯是逆到他那个。
就这个方法，因为我之前
没有来用的，我都没见过什么。你懂啊？对于人的开光嘛，因为就是没办法做不出结果的时间点就没骗了。
对啊。要么。
因为他还在法院。
老师的 B.B.A 的测试结果到因为说给我这个，
这么你在主要培训的。他有没有？如果你们空气的话有没有毒？他有没有吃药？如果你只能根据他所给吃药的，就是说给他的给他吃药，然后他的话两条分，然后他的这样分。对，因为咱们这个标准一个发明设备，因为如果最大的问题是你这个发言非常的。
那这个东西的话，那哪个对方来拿？这个
对对对，说法可以发展。DSME 需要找出来买，我可能不打算考这个部分，不打算考这些大的。
先收他，先收他了。
因为逃避，他一定逃避，不能避免。今天我说的能比那个大了。啊，
我看是他们说这他还有那才会选的，还有人说这现在不选，还有拿这个他。
今天到了，说话
好，这个不是这样。
能做起来，他离那个了，他不是，有吗？找的公司都是因为跟那个把地球用是我的厂。
现在没高考了。
有没有？结果开。多多有点，
我都不知道，太难想象了。得到那个差不多 P score 之后，然后就做了。P score 它是，比如大于多少，它就是倾向于1，就把它认为是缺陷，是吗？对照什么？
因为
没有就理派，
哦，都厉害了。
我弄。好的，痛，我开始痛了。我 key 分就是无法。
想要什么时候就拿那个然后在那里评分，然后我觉得很恶心，然后想让我们结果就开始那块了。对啊，就是直觉出来，然后你找一个那个是，所以我觉得这个，所以我
So please fill in just to make sure that you don't feel too anxious about the final test is what we covered today because it's all conceptual. So don't expect it to appear in the exam. Hope that because this class is like if you go too deep, it's very difficult. So I just the scope of the test will be up to machine learning. So the Lyso regression, the random forest is I think the last thing we cover. Okay, so. So today's if you forget, it's okay. Okay, but I guess it's good to learn more than learn less, right? Somehow. At least you know the term. You can throw the term to the interviewer, right? I know PS score. I know I know this kind of stuff. But he didn't know. But at least you learn it, right? It's okay. So some of you actually asked me one thing is how to use the PS score, right? Remember how you do it is look at the exact matching or the cost matching is you subtract what you have compared to what you don't, right? So that means that you have to subtract something, or right? Then the PS score will tell you what are the data you're going to subtract, right? Because remember, we do the PSM, right? Sorry, the nearest neighborhood. Just look at distance, right? But you can use the PS score to calculate, weight all the observations and calculate what are the 0, what are the 1. Yeah, give the weight to each observation, whether there's 1 or 0. So that kind of style. But I don't want to go to where you can imagine that's the more sophisticated way to do the nearest neighborhood. What's neighborhood in terms of the probability? So I hope that's easier, because this is in terms X score, but in terms probability will be better. I hope that is better. But oh, sorry. So I guess if now you go to Shenzhen, you don't need to scan the code, right? You still need the code? No need to use the black horse, right? It's black code, right? So probably you can tell me how fast we're covering this course. Then next year when we teach again, then probably we can adjust, because this is first where we teach. So I'm pretty sure that there are a lot of imperfection. Whether you probably can tell us what we can teach more later. Because usually people don't leave comment on the course evaluation. Maybe I should send out something to ask you to tell me more, because we can improve our course, right? But so maybe we can take a look what we're doing, what we're telling me. Let's go slowly. Okay. Wow. When using regression method with functional form, if we would like to Barbarossa recommendation. Yeah, well, I go to the very low cheap place, so I don't have a good recommendation. I just go. Yeah, it's very the quick cut. So I don't know the Japanese quick cut. So I don't know whether it's good recommendation. With functional form, you like how much independent variable speakers in front? Oh, that's a very good question. So so the question is, if are we able to say this? Usually we don't care about that. When you would try to standardize, this is something we skip when we talk about regression. Usually when you do machine learning or like the Lyso regression, usually the practice I skip is you would do the standardization. So you would usually subtract the mean and over the SD, normalize it before you run it. Then you run the Lyso, because they would not change anything, right? So in that case, then you can easily see. But if you do standard regression, usually we would not ask this question. So usually we don't do that. I'm not sure if I answer you this. If you try to do that, that's okay. But I'm not sure this is meaningful. You can do it, that's no problem. But I'm not sure this is a meaningful question. But when you do Lyso regression, or you don't cover in this class, is usually you would just standardize it. The reason why you standardize is because, remember, the Lyso regression. Let's go back to Lyso. What I talk is out of syllabus, okay? So don't worry about it. because some of you asked and I have to answer it. Out of the syllabus. So if you want to take a nap, you can take a nap, continue. So LISO means topic 6. Is it? Topic 7, I guess. Sorry. For the LISO, if you still remember, is depend on this guy, right? And the size of this guy actually related to the scale of the X, right? So in order to make sure that when you not bias the scale of measurement, right? Because if you reduce the X by 1/10, the beta will increase by 1/10, right? So that's why you want to avoid the scale problem. Usually you always when you run the LISO, you always standardize it. So standardize means you subtract the mean, make the mean 0 over SD, make the SD 1 before you run the LISO. But I didn't cover in this class, okay? This is how you do LISO, and that would be more meaningful. But when you run standard regression, I mean that there's no meaning, because you again take a derivative. I hope I answer the question. The scope of test, yeah, I said the material to be appear in the test will be up to last class, not this one, because today we just cover conceptual thing. So I think it's better not to do it because I focus on apply. So I will give some sample question, then you know the style, the type I'm asking. Okay, I'm not giving the whole question paper because that would be no point. Right? I give some question, you know the style. Maybe I give one regression question, one machine learning question, then you know what I'm asking. Okay, I maybe give 2 sample questions, then probably you know what I'm asking. Okay, so to relax your, make you feel more comfortable. Open book, open note. But the problem is whether we allow you to bring your computer. So actually for me has no issue. Okay. So let me know. Do you think it's okay I allow the computer to be there? I mean the problem. Okay. The problem is if figure out someone cheat with the computer, we have to take the exam again. That's the only thing. So if you trust your classmates not cheating, if no one cheating, I don't have issue. So who want to have computer with you, you can raise your hand. I can decide. You want to bring your paper or you want to bring your I allow laptop? So let me ask the question now. I mean, we can decide. We should. So raise your hand if you think that I should allow computer. No? Only one? Okay, then just use paper. We just don't use computer. Okay? Just bring whatever you want to bring, that's fine. Okay? Don't use you can't use a laptop or a computer. Okay? An iPad. Unlimited. Unlimited, whatever. Random forest, yes. Random forest is part of the question. Okay. It's sunny outside, rainy in my heart, and storm my brain. Oh, that was very good one. I like it. That's a good one. I like this. This is good. This is good. I like this one. How to make a Hong Kong girlfriend? That's a good question, and I have no idea because my wife is not a Hong Kong, so so I have no good idea. Yeah, it's not. I think it's not easy. This question. I will about the progress and completeness of group project. So we don't have class next week, so hopefully you can spend 3 more hours for our project. But So you do your best. That is the thing. It's just like try to present what you have, and we try. I mean, this is the learning process to do the project. So you present what you have. We try not to be very harsh because I know many of you are very busy. So when you give your grade to your friends and classmates, try to be more friendly as I do. So hopefully it should be fine. Okay. It's okay. I don't think any one of you are stupid because you are in the program. So everyone of you should be very good. The only troublesome is either it's probably not you're stupid, but probably I didn't teach very well. I apologize for that. But if you think that the material is too difficult, please do email me or email TA, try to help you. We try our best to do it. And try to ask your classmate together, discuss. It's very important learning process, right? Because you guys have class at the same time. It's good to improve together. I mean, and the master level, I don't think we have big restriction on the grade I can give. So as long as you do well, I can give whatever you deserve for. So shouldn't be an issue there. So if you're doing well, should be fine. The question is why exogenous source of variation is bad for conditioning. Because when you condition that, you can't discover what you want. So the question is the following, right? I think it's a good question, which it deserves some explanation quickly. So the question is like this, right? Why I control this is bad for that. If we regress y with x and z, all the variation of this will be captured by that. That will be very close to zero. Suppose this is only source you're doing, right? Suppose this is you change this and this changes, then it's absorbed here, right? You want the regression x, y, z, all the coefficient will be in z, not in x. So you cannot discover what you want. So it's not that if you do prediction, there's no problem. But you want to say x cos y, if you control what is changing x, then two things is problem. One is they're correlated, so that's why the regression is very bad. The second is you can't cover this, right? Since you only care about this, not this, then you don't need to worry about that part. Is that clear? I hope that's clear. Because you want the regression, you will know. If you control that, basically you get the coefficient is not significant. So you the bad thing. Okay. I hope I answered the question. Okay. Hopefully. Pass exam? I guess everyone would pass exam. That would be, if you take the exam, usually you will pass. That's not a problem. I mean, not joking, but usually you would have no problem passing. But whether you got high mark, I cannot promise if you don't study, right? But if you study, yes. Only coffee can keep, yes. Not just coffee. I recommend milk tea. It's also very good. Yeah, you will pass. I'm pretty sure if you have attended the class, you know where the lecture notes to look at. You should pass. Okay, pass is not an easy always. At your level, master level, the problem is whether you get A minus, B plus, right? So that's not a problem. If you attend the class, right? You do the assignment. Yeah, I'll give a question. Probably one question for the machine learning question, one's regression. Then you know what I'm asking. Okay. So basically, is I give you the output. I ask question based on that. So I'll give you. Don't worry. Quiz is very difficult, as I said. Quiz is making sure that to let you know you don't know. Okay, that's a purpose. Okay, that's why I said more than half you get full credit, right? So that's the meaning. Okay, and yeah, hopefully answer the question. Okay, I think someone is have storm in their brain, so must be today is Friday. Okay, there's no dispute, right? There's no time zone. This is Monday, so I can't accept the Monday answer. Maybe I should put this as one of the questions in the yeah. I should put this in the question. Maybe, and I also put my picture and other photo of other instructor to see if you know who is the instructor. then I know whether you attend the class or not. Okay? Is it raining? Okay, that is very interesting. Again, I don't accept this. This is okay. This is okay. I don't know, but yeah. So everyone knows this causality, the problem, IVRD, prediction. Yeah, that's causal. Yeah, that is the key point, I guess. Not covered in the exam today. Yeah, this lecture, yeah, that's true. Well, but I mean, you shouldn't be too pragmatic when you're in the. I mean, you can be very pragmatic, practical when you go out, but when in school you pay your tuition, right? You should try to learn as much as possible, although it's not there, right? At least probably you ask one question. This last lecture, right? So probably I'd let you know one thing is, you learn so many stuff in the lecture in the master course. No way you can remember all, but the main thing is to remember the framework, remember the big idea, such that when you actually require them, go back, right? I mean, I now for more like 40 years old, right? Then how many years I have studied, right? Since I was 1 or 2 years old, right? I learned so many years. I can't remember everything, right? But the thing is, I know where to pick it up when I have a problem. So the question is, you learn more, you know more, you know the scope more, then you can come back. Okay, it's not to remember everything. So that's why I always open book, open note, because there's no point to remember. I mean, of course, you at least remember the framework where to figure out. Okay, so I hope that can help. Most of you still follow. Whoa, this is the most funny thing. Usually you have something behind, but not easy to follow today. I understand it's not easy. This topic, as I said, it is usually covered in the PhD classes. Usually cover the second year PhD courses sequence. It's something very deep. But I try to give you the names and something you can go. White shirt? Did I wear white shirt at all? Okay. Did I actually wear white shirt at all? I might be even day. Okay. I will try to wear the white shirt on the presentation day. Okay. I remember that. You want this? Okay. Next time when you present, I can bring that. I can bring the lai cha. If you want anyone, just take. Okay. Oh, why so hot? That's a good question. Actually, I never have this hot in November in Hong Kong throughout my life. This is very different. Usually in October, even mid-October, usually I wear long sleeve. This is a very unusual year. So whether good or not, I don't know, but it's very unusual. You need medicine. Oh yeah, that is I need as well. No time to go to Shenzhen. You can do it next week, okay? You can go Shenzhen in the afternoon, Friday. Okay. Oh, okay. So the question is, who is you in this class? So who is going to love whom? No, I mean, who is going to? I mean, yeah, I don't know. In the old days, I don't know when in the high school, I don't know in China, but in Hong Kong, you usually send this to write something to your classmate. So, but now people write it on the U reply. So I think it's fun. So I think if something happened, let me know. I mean, send me an invitation when you get married. Right? I guess some romantic may happen after the class. You want to drink milk tea? Okay, I will bring milk tea next time. Oh yeah. Seriously? Okay, I will bring more. I will bring more. Okay. So I will try to bring some more drinks when we have presentation day. Okay, I try to bring. Yeah, I try to bring more. Yeah. So we'll do the very last one. We're very quick because don't worry. Only the main logic is there. So don't worry about that because the methodology is very simple. So the last topic is talking about the diff and diff and the panel data. The idea of diff and diff and panel data is exploring the fact that the time dimension, okay, time dimension. Okay. So diff and diff is something that actually very useful, very good. Okay. The idea is you look at treatment or untreat. Okay. If you just have cross-sectional data, we observe them once, they have medicine or no medicine, then it's very difficult. Okay. But if we have the data over time, no one took the medicine before, and this is period 0, and period 1, some of them took it. Okay. Then this can help us to do the prediction. Why? Okay, let me draw a picture, then you explain everything. Okay. Let me draw a picture. Okay, so I have one guy here and one guy here. Okay. And one guy here. Okay, 2 guys. Okay, now this is the t equal to 0. Okay, we are taking it how well he's doing. Okay, how well he's studying. Okay, now t equal to 1. Okay, again same. Okay, okay, what happened? We have some treatment here. So treatment, okay. So then we'll look at how this in a relationship, right, affect his welfare, right? Whether he's happier or not. Okay. We're happy and cry or just cry because of sad. Okay. So the question here is how you look at this, right? Because if you look at cross-sectional, look at here, then it's not clear, right? You compare these two, it's not clear that the difference is due to individual difference, right? He is sad because he's going to study the exam for our class or not, right? So the thing that is you would want to compare it to its own past, right? Like compare to its own past, right? Then you control the individual effect. Is that clear? Right? But why you need to care about the control group as well is because of how this change over time, right? This is the beginning of semester, right? This is at the end of semester, right? After a torture of 1 semester of statistics, right? Maybe you are very happy, you're done, right? Or you're very sad, right? Depends, right? But you need to want to compare these two effects, right? This is change in the background. This is change of treatment and the background as well. You take the difference among these two differences, that is called difference in differences. Is that clear? So let me repeat because this is the overreaching idea. Okay, then basically done. Okay, because we want a regression. That's very simple. The math is very simple, but the idea is very deep. Okay, because I do a lot of research on this as well. Not this, okay, but this is the same math, the same idea. Okay, so is you want to see whether in a relationship make you happier, right? He just met a girl at the end of semester, right? And this goes on, right? So the question is, going through the master program, right, can be very happy, right? Or very sad, right? Once you get the degree, very happy, right? So, but you have to compare this, okay? This is the difference, and you take the difference, okay? So that's the idea. So to implement this is very simple. We just run a regression, okay? And the regression, you run, well, where is that? It's not there, okay? It's very simple. Let me write that down because it's just one line and you're done. I don't know why so many slides. So just wonder why, which is how happy you are. Run intercept, beta is whether you get treated, means that you get a girlfriend or not in the example, right? And you will have beta 1, beta 2 is whether before or after, post, dummy variable. 1 is before, so 1 is after, right? 1 is after, 0 is before, right? And this is 1 if you have girlfriend, and 0 if you are not. Okay. And you have this treat times post. And that is the regression you run. Just OLS. So although we call DID, it's OLS. Right? There's nothing deep there. It's OLS, just OLS. Of course, you control bunch of conditioner. Right? That's OLS. That's that simple. Nothing deep there. Is that clear? So there's nothing deep there. Right? You just look at, you have, remember the data we have is like we have 4 information, right? We have Y is here, Y is here, Y is, we have 4 observations, right? And each observation, how happy you are, right? And this observation, right? This is, in this case, right? This is treated is 0, right? And for him, post is 1 afterward, right? And for this, treated is 1 and post is 1, right? And for this guy, treated is 1, post is 0 because it's before, right? And this guy, treated is 0 and post is 0, okay? You just run the regression, right? Look at how happy they are, right? And then just run the regression. That's very simple. Because it's basically run the regression, right? You just different timing, you just give this control. Just run it and then you can uncover that. Okay? So that is that simple. Because just OAS. Nothing very special. Okay? For some of you, I said I run a lot of regression. On finance, it's actually I do a lot of event study. It's looking at, say, one of the paper I work is look at finance return, financial stock return, daily return. Look at during normal days. This is how the price changes after a day. And one of the paper I look at is on a day where we have a special event, like we have World Cup, we have a China football team wins, right? And how this changes. Or before Christmas, before Chinese New Year, these are the special day. So it is very common to use in finance and accounting, many things as well. So you can imagine, same for an IT case, right? It's very simple. You can look at the traffics, okay, during the special holidays, right? How it changes compared to the normal days. Or you impose, you try to say, consider your IT, right? You have the website of Chinese, I mean, you have website of one website, you have another website, right? And one website, you impose certain thing, and then you can compare contrast, right? Or you can randomly assign a special program to some kind of the consumer, right? And then you can see the impact, right? Maybe you select some consumer to receive special scheme, right? You're being selected to do this, then you can compare and contrast. But this is very often in IT, right? Some of the consumer is the VIP, have a free access to the system and see how it works, right? I think that's how usually they do, right? So that's the ID. And that is pretty much of that, okay? And all the rest is just basically just a detail. But the regression is this, there's nothing more than that one. Okay, I'm not going to go to the example, But instead, I want to, because you can look at this, it's just simple. You can look at the Python code, right? It's just, I have time dimension, treatment dimension, and outcome. Then what I do is I just run the simple regression. Okay, nothing is OLS, there's nothing deep there. Okay. So what I want the last 1 minute, I want to talk about panel. So don't worry, 1 minute is sufficient. 1 or 2 minutes sufficient. Okay. The idea of panel is very similar to DID in the sense that we no longer have a special event that compare and contrast. Okay, you can imagine in general, we don't have a specific treatment stuff. Okay, and for example, the question is, I look at the Y is the income. Okay, X may be just education, and we're a bunch of variable over time, right? I look at the guy, how much you earn, and other characteristics, and there are many of them. That's called panel data, right? I have a guy observed many times, and I may have many guys. Okay, and then what you're going to do is actually not too much different from our time series data. You take the difference, right? Subtract it from the last period, and run the regression. Okay, and that is actually we call the FD regression. Where's the FD regression? It's gone. It's called FD regression. Okay, take a first difference. It's the same as what we learned from the time series model. Okay, and the other one, actually even more stupid. Okay, is very simple. That is called the FE regression. That is nothing but just add a time dummy there. Okay, let me put in perspective this last slide, because just regression, there's nothing new there. So you can imagine I have a data here. Okay, I have a guy number 1 here. I observe over many times, right? T equal to 1, T equal to 2, T equal to 3, and I have a lady here, right? Again, number 1, number 2, number 3 here. Okay, that's very simple. I just run regression. Okay, having what we call the identity dummy, ID, and also the time dummy. Okay, so I run the standard regression, but in the sense that I would say, okay, this is ID, this is a guy number 1, guy number 1, guy number 1. Okay, ID 1, and ID 2, this is 1, right? ID 2, this is 0 for him. ID 1, this is 0. Right? Dummy for each guy. Okay, and I also have the time dummy. This is T equal to 1, T equal to 1, T equal to 2, T equal to 2. Okay, and that's it. Okay, but usually you have T1 equal to 1, T2 equal to 0, and T3 equal to 0, and this is T dummy for each one. So on and so forth. Okay, so this is called the fixed effect model, right? So basically, it's just you run this model. Okay, and of course, I guess most of you don't care about the math. So what you do is just use the linear model. You install that called PanOS. Okay, and once you did it, okay, I'm sorry, I will work just the last few sentences. I don't want to take more time because you want to go home, I guess. So yeah, the PanOS, the same regression, you run, then you fit. Okay, and similarly, if you try to run the fixed effect model, you would use the first different OS. Okay, just linear model again. You just fit the formula, then you're done. Okay, I'm not going to bother you with the math here because in order to do that, you actually need a good training for that. but in a class, we really can't do it. But at least we know that if you're panel data, you can do something, okay? But I hope the minimum thing that you remember from this very rough exercise is this. I hope this picture stick your mind to understand what the difference, and it's very useful. Okay, and as I said, I use it very often, and the panel data is also very useful when you actually go to do policy work, and many of the you may imagine, I mean, just final remark, right? Is a lot of IT firm, they have a data scientist or the department, right? The Netflix or the TikTok, right? All of them algorithm, right? And algorithm is based on data, and these are based on data analytics. All the technique, of course, very simplified here, but they are very useful. And you look at who is the Netflix CTO right now? It's an economist who do this kind of stuff. Of course, he learned along the way, but it's something that, I mean, this thing actually go very long way. Although we focus on very simple stuff, but even the complicated one actually work in practice is not too much different what we learn. But we're just being careful because of data issue. We have to be very careful how we estimate them, how to adjust the error, or the model you're using. But all the ideas already embedded here. So I'm sorry, a little bit rushed at the end, but I guess the time is more well spent when you learn to do presentation, because at the end of the day, you are a joint degree of computer science and B school, right? So having you learn how to do presentation, I think is the most important. And actually for me, I think my undergraduate education from B school is teach me how to present. Okay, although I don't think I present very well, but I think I'm average, right? But if I don't take the B school, then we'll be below average. Okay, so I hope during this class we learn how to present, and then you present your work. I hope to learn from you 2 weeks later. Okay, no class next week. I will see you 2 weeks later. So you will be like a 5 hours, 6 hours meeting next time. Okay, combine 2 classes. Okay, so see you. Thank you. So I'll give more instruction on the presentation later. Okay.